are talking about data systems and applications. We are talking about data patterns, trends. We are talking about data types and all that. So what really is the mining data? What really has to do with mining data? It's simply trying to source data and trying to dig deeper into data. It could be structured or unstructured data that forms part of the data type. You can see my data my cursor rolling on it. So the data type has to do with structured and unstructured data. I'll talk more on the unstructured data. Unstructured data can be anything. It can be videos, it can be pictures, it can be. It's not structured. It's not placed under proper context, so you can't really classify them. Some of them are text messages. It comprises of a lot of things. So mining these data falls into the jurisdiction of data science. Then there is another aspect of cleaning and validating data. So cleaning comes in. So when you get a messy data, for instance, when you work with an insurance company, let me not go into insurance company too much, but for the sake of the students, let me deal with student data. So if you get student data that has a lot of variables, okay, and some spell checks, some spelling mistakes, some data errors, what do you do with it? Can you work with it? Is it possible to get some insight out of it? So when you get the data in whichever form it is, you have to clean and validate it and make sure you have a good data to work with. And what that does is it gives you some level of accuracy in your data. You also want to ensure that your data is actually complete. The data you need to do whatever you are doing is complete and it's uniform, so that you don't have some data which do not fall into any category or any categorization whatsoever. You also want to talk about models and algorithms, and that's when we are getting more deeper into data science. So in data science, you have to know how to develop models and algorithms. The good part is that for most of you, for those of you that are into actuarial science or that have some bit of statistics and mathematics, modeling is the beginning of your getting into practice. Okay, so it comes handy. At least you are taught the basics of modeling some data sets while doing your thesis, dissertation, and whatsoever you do in school. So you learn the basic concept of modeling, but in data science, you do very high level modeling because of the data set you tend to receive. And you tend to write algorithms. Algorithms simply has to do with logic, getting a logic to work in your models. And we use them in very huge data, and it's also used for predicting. So the other thing you want to say is that the concept of data science actually covers patterns and trends. What am I talking about when I say that? So what we do most out of data is to identify trends and patterns. That helps us to make informed decisions. So if you have a set of data, depending on the trend that is coming out, when you have projected them into visualization forms, that is whether it's a chart, whether whatever it is that can make you spot the trends, you put them in that form. So identify patterns and trends are key in data science. Then let me go to the last bit, which has to do with data systems and applications. And that is when you want to go a bit deeper into the data science. Some are data collection tools. That's the basic form of data applications you can find. So others are also online. For instance, when you are signing up for a system, when you were signing up for this particular webinar, we asked a few questions, your name, why you want to join, and all that were asked. What was designed for you was a form of data application. So it might have been created in Google, but the interface of it is a data application. And the system behind it that makes it actually work for you is what we call systems. So there are databases that are connected behind the systems, the infrastructure and all that. I think we'll come back to this. Let's just proceed so that we can work within our time. So the next thing I would want to talk about beyond the concept is to talk about the usability or the application of it. Right. So, okay, let me skip to the next slide. We'll come back to this because there's something in the next slide that I would want us to. So let me deal with the next slide. The next slide is actually why should you consider data science as a student, as a new graduate in the space, in Kenya, in Africa, if even you decide to go to America, why should I consider data science? I give 5 main reasons. That there might be a lot. I'm sure you must have been researching, so you have seen a lot. The one key thing I would want to mention is that there are numerous applications. If you ask me, I will tell you that data science has no limitation in terms of application. It has no limitation whatsoever. So it's applicable in every field. So far as there's data in the marketing space, you can apply data science, right? So it has no limit whatsoever. Wherever you can find data, even in your churches, there is data. In your schools, there are data everywhere these days. You download an application to ask for a few information from you. That is data. Everything we are doing by the day in our generation and in our world is data. So in every space where you find yourself is applicable. Okay, but I now let's go back to the last slide. So one of the reasons that you would want to consider data science is that it gives you no limitation. Unlike if you compare actuarial science have main practice areas where actuaries actually function. Though, from my perspective, I think actuarial science does not limit you in any way. From my perspective, I think what education should do to you is to give you a level, to make you a level-headed person, so that anywhere you find yourself, you can actually apply what you need. Okay, so now back to what I was talking about. It has an outstandingly numerous applications. So a few of them that we know of, like I keep saying, data science has no limitation. So in the insurance space, it's applicable. In the banking space, it's applicable. Like I mentioned, we just happen to have made a medical underwriting contract, and we are using data science. The original system actually uses actuarial models, but we are migrating into a data science model. So you see, data science is applicable here, and this is used in the health insurance industry. You can also use this with the reinsurers. Then there's claim analytics. That's another system we are building. You apply a lot of data science when it comes to claims and analytics. There's also reserving. Recently, I happened to have chance on an online video that was talking about actuarial reserving, applying data science, predictive models. Okay, I went through and I figured that this data science has come to do more than we expected. And from the information I got from that video, it so happened that they are giving very correct estimates. In fact, their estimates comparable to actuarial models that have been used to project reserves. So it's playing a key role in that aspect. There's also fraud detection, and that's another thing I would want to talk about. When it comes to fraud detection, finally there are new systems, no SQL systems like new 4G and others that helps in detecting fraud quite easily. Of course, you can use the normal SQL and other database systems to determine fraud, to work on fraud. But I think the NoSQL databases are doing quite well when it comes to that. And that also forms part of the data science terrain. When you come to banking, it is there. When you come to education, it's there. Education, that is something I would also want to talk about. Adaptive learning. In adaptive learning, it has to do with trying to customize the learning to suit the learner. Okay, so you develop systems that try to interact with the learner, and depending on the responses that the system is getting from the person learning, the system is able to fine-tune its teaching or its information to the person learning. A typical example is, for those of you, I know in Kenya, you do more of the institute and faculty exams. But when you come to the SOE, for the vendors, there are various vendors who sell adaptive packages, because the SOE system is more like an MCQ system, so a multiple choice system. So when you are taking the exam, depending on your responses, the questions that follow actually are tailored to your understanding and to help you to be able to get the things better. Okay, I think the same system is used for GRE and GMAT exams. So you take some exams and you realize that the more you are answering the questions, they become difficult. That is an example of adaptive learning. Okay, there's also education, BI, and visualization, which we will not go into that. So again, the other aspects of usability has to do with marketing, CRM. So in marketing, once you are getting data from your marketing team, you should be able to use it for productive insights for your business. Then there's also the health space. And for me, that's where I have interest in. I believe that the health system has not been tapped. The health industry has not been tapped, because there are lots of information from the health industry. And for those of you that would want to go into data science, trust me, it's an area you want to venture into. There is a lot of data which is not being used. So when you enter into a typical hospital, they are taking your name, they are taking your vitals, your telephone number. Then you go back to the doctor takes some information from you, do a diagnosis on you, you go to the lab, you go to the scan. These are lots of information that they are collecting. But unfortunately, in our space here in Africa, it's not being used. The data here is not being used. So it's one of the strongest area you would want to venture into and turn data into insights, so that people can get much information from it. The other thing you want to talk about is the recent issue of the corona. We've seen data being populated on the mortality of corona in the various regions. When you talk of America, when you talk of the Asia, when you talk of, everybody is coming out with data in terms of the mortality issues, whether they were actually due to corona or some people have underlying health issues and all that. So for me, the health industry is huge when it comes to data. It's applicable in the mining sector. It's also applicable in technology. Okay, so now let me go back to why consider data science. Okay, I used the first reason why you should consider data science to talk about the usability and the application areas of data science. So now let's move to the second one. I would say it's financially rewarding. Again, when it comes to Africa, it's not this is not directly applicable. Okay, because of the fourth reason, which is that data science is still young in our space. We have not utilized it enough. So we really don't see the value of it. Our industries don't see the value of it. So employers who employ a data analyst yet would not value his services like it's supposed to. I'm not saying would not value it at all, but then the level of recognition and financial premium that should come with the kind of job they do is not what is done here. So it is relatively young, and that is my fourth reason, and promising, because in fact, if you ask me, I would say that Africa hasn't taken off when it comes to data science. We haven't taken off. We are just at the peripherals. We are just about beginning the whole data science. The reason is, one, people are still learning how to use data tools, data analytic tools. The understanding of what data science is has not been really perceived. We haven't gotten it like we should have. Okay. And so the other bit is that the experience is there. We have very little experience in this in the space when you look at it holistically. Okay, so it is very promising. It is very promising. As a matter of fact, data science had only commenced in over the last 10 years. Though it came a while ago, I think they were captioned more under statisticians. They were added to statisticians. But the coining of the term data science actually is relatively 10 years old. Unlike actuarial science, which is more than 100-year-old profession. Okay, so for us in Africa, and if you want Kenya to be specific, I would say there's a lot of opportunity in the space. It's very promising. It's very young. Not too many people are in the space. In fact, for majority of the application areas, people don't even know how you can apply it. When you go to the health industry, people don't know what you can do with data. When you go to aviation, people don't know what you can do with data. When you go to agriculture, that's another space where there are lots of information. Those who are into agriculture insurance will tell you they are constantly collecting data, but the fact is they don't know what to do with the data. So it's a very promising area for us in Africa. Even in the US, it's estimated that there are still about 40 million data analytics or data science jobs that have not been filled. Even in the US, where they are well advanced in data science and analytic issues. So for us in Africa, it's a big deal, and especially for those who are studying actuarial science, statistics, and anything mathematics. It is a space for us. We have the quants. The modeling scale is already available to us. We only have to develop it. So the opportunities there are huge. You only have to identify the space where you want to penetrate. The only problem is that we are all focused on the insurance industry. and that is the wrong thing they are doing. I would speak more on the opportunities when we come to the last bit of it. The other aspect I would want to talk about is great career path. So when you come to the data science space, the career options are quite a lot in terms of the roles that are defined for data science career holders. So you have quite a number of them. Data analysts, business analysts, and all that. There are quite a number of them that I'll speak to very soon. So the other thing I would also want to talk about has to do with the use of what I call the next generation tools. Okay, these are actually applications or tools that are applied in data science. So you want to talk of the Pythons, you want to talk of the R's, you want to talk of the MySQLs, you want to talk of Hadoop, you want to talk of Hive. There are a number of them. There are a number of them. But for us, the basic tools that are available and most widely used are these three: Python, R, and SQL. And these are tools that are not far from us as actuaries. MySQL has been used for a very long time in the actuarial space. Those people that it's been used for a very long time. I remember some years ago that's I read a couple of papers where people were using SQL in their actuarial research and all that. So the SQL has been there for a long time, and it's very helpful once if you are able to get SQL on your tips for as a beginner. So for me, if you ask of my advice, I would say that look out for the three main tools: Python, R, MySQL. Hadoop and the rest are not too needed at the beginning. But as you go on into data engineering and all that, you need some of these tools and cloud architecture. You would need some of these things to work with. But as a beginner, as a graduate planning to enter the data science space, the three key tools you would need, the next generation tools you would need, is Python. In fact, it used to be R, but I see that Python is overtaking R now, and it's being used even in academic circles. So for those of you still in school, you may have access to that. The good thing to do is to start learning how to code in Python and R. MySQL can come later. Right. So let me move to the next thing, which is the career pathways. Okay, so in the career pathways, there are a couple of them I would want to talk about. There are numerous. There are numerous actually. So the first one you usually start with is a data analyst, and that is usually a typical actuarial analyst function. So it has to do with cleaning data, it has to do with manipulating data, preparing reports, dashboards, and all that. Then there's also business analyst. The business analyst has to do with looking at the enterprise-wide view of it. So they try to get insights from the data they receive out of the whole business process and inform management to make better decisions on that. There's also data engineering, and that is a space I like most. You work more in the background. It has to do with processing batch files and preparing data pipelines and maintaining them. So data pipelines has to do with creating the access points so that data can be processed in real time. So when you go to the bank, when you go to the ATM and you put in your ATM card, there are data pipelines that are actually connected at the back end, and that helps you to process your withdrawals, whatever you want to do there, whatever. It helps it to go faster than expected. So these are huge spaces that you can get into. There's also the data architect, and data architect mostly has to do with designing database and trying to improve their performance over time. So all these people, and there's also the actual data scientists. And the data scientists also analyze more of big data and complex. It doesn't have to be in a systematic order, whichever way it is, whether it's structured or unstructured, whether it is text or numbers. The data scientists have to be able to derive some meaning out of this and give it to the business to make decisions. So I also see they support business decisions. Then there's also machine learning engineer, and that is the new space. That is where a lot of people are entering now. So people are having to do more of AI. Again, the artificial intelligence and all that falls under that scope. So developing algorithms to be able to make predictions for systems is one of the things you want to look at when you come to machine learning and all that. So there are lots of them, but I chose these for the purpose of our presentation today. Right. Then I also look at the requisite skills. I know we are running out of time, so I'll brush through this. I'll try and send the slides, do some editing, and add some more information and send it to you guys so you can have a fair view of what we have actually discussed. So when you come to the requisite skills in the data science space, I say you need technical skills. I'll come to that pretty shortly. So let's go from the highest to the lowest. So I would say you need analytic skills. And if I'm right, that is to say, if you guys are mostly actuarial science students, then that's good. You need some quants, but I didn't mention that because the quants in there isn't so much needed, but your ability to be analytical is what's needed. So under the analytical skills, you want to know how to organize data. You want to know how to manipulate data. You want to actually know how to analyze a model. And you want to be able to visualize, create dashboards. And that's where Power BI comes in. Okay. R does a good job. And when you want to do R, in this case, even when you add R Shiny on your development, it makes it more nicer in terms of your visuals. When it comes to graphs, when it comes to other visuals you want to show, combining R Shiny and packages in R actually helps a lot. Then Python also has great stuff when it comes to visualization. And that's also comparable to Tableau, which is also good. We'll come to some of those things very shortly. So I say that the analytic skills must be very high. You need at least 95% of it. And I'm glad that most of you are into stats, maths, or actuarial science. At least those things come handy. You only need practice to be able to know your stance in it and know that you are good at it. But you need like a 95% of it for me. Okay. Then you want to come to industry knowledge. Industry knowledge has to do with when you have actually found a space to work with. Okay, so assuming you find yourself in the insurance space after your school or after graduating from school, you want to understand the industry trends and growth when it comes to analytics and when it comes to tools that people actually use. You also want to have a product sense. When I say product sense, I mean understand the products of your industry. So, for instance, if you are in the life insurance industry, you want to know their universal life policies, all those things. You want to understand them well. The reason why you have to understand them well is that you are going to get data from universal life policies. If you are in general insurance space, whether it's motor or auto insurance, I don't know how it's called at your end. You are going to get claim data from it. You are going to get underwriting data in respect of that particular product. Okay, so you need to understand the product very well. Okay, that helps you when it comes to the analytical bits. You also need to understand how to manage the product, and if you happen to delve more into actuarial science, actuarial practice, you understand what is called product management. In fact, in product management, you have to understand the output of the product when it comes to profit. You have to understand when it comes to distribution. All that is related to product management. So it doesn't have to do with the insurance product alone, but also analytic products. That is when you are into technology and you develop systems, they become products. So you have to understand how to manage it. You have to understand the industry, how the industry is doing in the market where you operate. Okay. Then you want to talk now about technical scale. And that is when you are going deeper into data science. For you, the reason why I say 50% of data science and technical skills is that at the entry level for graduates, you don't need to go into system designs and architecture. You don't need to go into algorithms and production. Okay, yeah, but you need a certain level of coding ability. You have to understand how codes work, how to write codes in Python, how to write codes in R, and how to query data. So some of these things are important as a data science entry level person. Right. So you need a minimum level of technical skills. And for me, that should be your ability to code in Python or R. When you get into the space where you can understand more on system designs and architecture, okay, and developing algorithms, which is super important, and productioning. Okay, so let me speak a bit about productioning before I go on. I figure that our time is almost up. So production has to do with starting something from A to Z. Okay, so if you start developing a product, the beginning of the product, the type of data that is involved, the type of analysis that you have to do, okay, the type of models, the type of binary operations you have to add, the algorithms. You have to understand everything to the end of the product where people are actually using the product and the outcome of it, how it is functioning, how it is working. Is it that effective like you anticipated from the beginning? Are there shortfalls? So that has to do with production. There is the A to Z of data science. I mean, its application. So you need that when it comes to the technical skills. But for an entry level, the minimum is you must have some level of coding sense in it. So let me speak briefly about the ASD model. So the Actuarial Society of Ghana, having understood this, the Actuarial Society of Ghana, having understood this, came up with a program we call Graduate Actuarial Training Program. And the Graduate Actuarial Training Program is purposely for a year. Right. So what we do is we actually collaborate with industry. And what we do is we place graduates, fresh graduates into these industries. And it's very competitive, very, very competitive. So what we do is that for you to be able to get into the rate, you must have some basic skill in Excel VBA and in R. Okay, because our interview process is not the usual interview where you come and we ask you, how are you? I'm fine. How can you be sure you are able to join the program and all that? We have a skill-based interview. So you come, we give you data, we say do X, Y, Z. So your ability to use any of the analytic tools, the next generation tools, will tell us you are ready for the industry. Then we place you. So you have to be able to do a lot with Excel VBA, and R programming. the duration, like I said, is for a year. So in Ghana, we have what we call the national service. The national service is that every graduate must serve the country. And so you have a period of 1 year post your university education to serve the nation. And that is when we take you through. So it's a very comprehensive process. We actually conduct evaluations with the companies. We actually assign mentors to the trainees. So there's a lot that goes into it. So that's the model we have designed for Ghana and for the actuarial students that are graduating in Ghana. So they actually go through this. A lot of them get to apply and go through the interview process. So like as I speak, a lot of them are preparing for their interview. So by now, it's very tough on them. Everybody is trying to make sure that they get into the shortlisted group. Now, let me go to the way forward. So the question is, what do I do as a graduate? How do I get into this space that is applicable everywhere? I have spoken a lot about it, and you think, wow, this is something you would want to get to. The first thing I would say is that your analytic skills is very important. And this is something you have to build in school. You have to get a big team from school. The basics are there, but you also have to make yourself available for that. You also have to be able to do a lot of research. I say 95% of research. The reason I keep saying that is that there's a lot of information online now that you can access about data science, about the tools, how you can use them in the different industries we have mentioned. And I'm happy to say that one of the industries we have been able to penetrate for the Actuarial Society of Ghana is the telecommunication industry. Partnership with some of the telecommunications, Vodafone, where we send five students, 5 graduates every year to their data science department. And they learn a lot. They learn a lot. So, and in that department, they do a lot of research. A lot of research, because they have to research on their clients. And you know, almost everybody now uses a mobile phone. So in the telecommunication space, it's being used a lot, but you need to do a lot of research to prepare yourself to get into the data science space. Beyond your analytics, a lot of research is important. We are lucky these days because some 10 years ago when I was in school, we were looking for information. But today, the information is available to you. In fact, the information is looking for you. That's what I say. Because everybody produces his work and puts it online. And it's available to the masses. The only thing you have to do is spend time researching about it. Then you have to connect. Connecting to the right people is very important. People who are into data analytics. People who are doing stuff that you want to go into. A typical way to connect is to get connected to Dynamics. I know they are doing a lot in terms of the webinars, in terms of the training for you guys in Kenya. Get connected to people, get connected to companies. You get connected to people, get connected to companies. It is very important. Then you also want to innovate. The reason why I say you should innovate is the fact that some of us are not tech savvy. Because when we go to school, the whole idea is to come out as first class students. So the only thing you get to do is always have your heads bent down on your books in order to get all the A's you want to get to. And unfortunately, our education system in Africa hasn't helped us. Personally, I don't think it's helped us because it's more of read and reproduce in the exam. And that's about it. So we focus a lot of that. But you also want to spend time trying to innovate and get into the tech space, and that gives you some level of innovation. when you want to think about new stuff. Okay, so like innovation has to do with producing new things. So the first level of innovation is to get a bit techy. What I mean by get a bit techy is try to understand how systems work. For instance, you want to start by knowing how to program in Python. And you want to know how systems that have been developed with Python works. And you want to think about how can you add something to it and make it more useful than it is now. Okay, so the best way is to start thinking of how do I improve things? How do I improve this application? How do I improve what I'm doing? That is the beginning of innovation. So innovate with technology. Then I want to talk about collaboration. Collaboration is very important. To get your work seen, to get your skill known, you have to collaborate with people who are doing data science projects. You have to do a lot of collaboration. And that's where you learn to do the debts. I'll come to that pretty shortly. Okay, I'll spend the next 5 minutes going through your plan, the plan you should do. I put up this plan. It's personal, but I think it's going to be helpful for you. Number one is to invest. Invest in what? Invest your time, money, and effort in training your mind. And this is where dynamics come in. I see a lot of training programs that they are offering. Not just them, there are other platforms online. You have to invest your time, money, and effort in trying to train your brain. That is where you get the knowledge. You get the knowledge on how to code. You get the knowledge on how to apply. You get the knowledge on how to move into industry with your skill and all that. You have to invest a lot of time in it. It is said that the average youth today spend 4 to 5 hours on his phone. If I were you, I would be spending those hours getting information. I had mentioned earlier on that you need 95% of what you call research. And that is educating yourself, training your brain. Then the next plan you want to do is to intern. I know in Kenya, probably you don't have the same thing here. We have the national service that gets people into industry. Okay, so the best thing to do is to try and get some internship. So you want to explore, and that I call it do the dirt. That is where you do all the dirty stuff, getting your hands dirty, coding, doing everything for free. But that is how you learn. Sometimes you don't need to intern for money. You intend purposely to gain your skill and experience. Some way, somehow, once you have developed your mind, you have to intend. You have to get some experience. That is how people get to know you can do X, Y, Z. Because what happens is, if you come to me and you want to say that you can do this and that, if you can't prove to me your past experience, it's difficult for people to hand over jobs to you. So you want to do some internship. You want to work to Zamara. You want to work to any other company in Kenya. You want to work to, and don't limit yourself to the actuarial space, like I keep saying. You want to work to an airline company. You want to work to an agricultural production company and say, look, your data, I see a lot of data coming in from it. You want to work to a big hospital and say, look, what are you doing with your data? And try to intern with them and see the loophole. That's where you get to find the problems. Because with data science, there's what we call problem definition. Anytime you have to apply any data analytic tool in your industry, you have to first define the problem. And one of the ways to start understanding problems in the industry where you want to go is to intern. That is where you pick up the signals and the dots. Then there is focus. I say you have to focus on one industry. I mentioned a lot of industry. In fact, if I were you, I would take out the financial industry and the insurance industry. It's a space to go to. Don't get me wrong. But I see a lot of people with actuarial background, with maths, with stats, focus on that. There are a lot more in the health industry. There's a lot more in the telecommunication industry. There's a lot more in aviation. There's a lot more in agri. There's a lot more in energy and mining. Those are the spaces that are growing in terms of data science. So you want to pick any of these spaces and say, I want to apply my data science in this space. So you give a lot of focus. So when you want to start developing tools, you look for data in that space. In fact, there are a lot of places you can have data. I will send Kaggle is a lot, is number one. There's a lot of data you can play around on Kaggle. And then you can do a lot of collaboration on GitHub too. Then the last one will be to impact the space you are. I call it creating your own space. So example is, once you have identified that I want to be in the telecommunication industry, your ultimate purpose is to influence and create a space for yourself. You want to enter there and be the number one person when it comes to data analytics, predictive modeling, when it comes to anything that has to do with data science, data architecture, data engineering, and you must make your impact. That is the only way. You want to ensure that in a day when you are not in the office, you receive 100 calls. That is when you are making impact. If you don't make impact, your value will not be felt. Data science, you are going to make or to focus in. You have to ensure that you are making the needed impact. Else you fade out space. So I think I would like to end here. I've taken more than I was supposed to have taken, and I also have a meeting to join now. So I would open for some questions, then we can proceed from that.
Okay, Mr. Mark, thank you for that awesome presentation. So on the question session, I think we are going to start with the first question that has been asked by Lucas Innocent Botti. Is actually saying that, Mark, thanks for your fruitful explanation of data science and its numerous implication. I would like now, other than coronavirus mortality issue, how can data science can create and direct actions that will make the economies of our countries be more resilient? So I think you can start by answering that.
Any questions?
Yes, I think you can start by answering Lucas' innocent question: how data science can create and direct actions that make the economies of our countries more resilient, or help to define the action to make.
Hello.
Are you getting me, Mr. Mark? Can you hear me, Mr. Mark? Hello? Hello, can you hear me?
All right, so the question has to do with how can data science. All right, so the question. Okay, so you want to. Can you hear me? Yeah, I got the question, but I want to know if you heard me. Yes, I heard you. Hello, I heard you. Hello.
We can hear you, Mark. We can hear you, Mark.
Hello. Wow. Oh, okay. So yes, I can hear you. So let me answer this question shortly. When it comes to national economy, you want to talk about data, okay? So, for instance, in Ghana, we collect a lot of data for economic issues, all right? So, we want to talk about the economy in Kenya, but what we do is we collect data relating to economic issues. So we go to the market, we want to collect data regarding the prices of goods and services. You want to collect data that has to do with people's employability and other economic related issues. So we want to talk about labor, data from the labor markets, data from those unemployed and employed. And once you get all these data, something has to be done to the data. Something has to be done, and that is where data science come in. We know the economists use it for their economic value determinations and all that. For instance, when it comes to the GDPs and whatever, but there are more data to be used. So based on the data you get from your economic sensors, or if you want statistical sensors, you can get to retrade in terms of employment. If you are collecting data regarding, for instance, graduates, you want to find out how many has been employed in the last year, how many get to be employed once they have graduated, 2 years after they have graduated, 3 years after they've graduated. You want to see the numbers. This also helps inform the government in terms of job creation. Not just the government, but also private persons who want to go into private business. They want to see the risk when it comes to unemployment, the risks that unemployment has on the industry, on the economy. So in terms of using it for economic deliberation, the law you can with data. You only have to know the kind of data you need. You only have to know the kind of data. So data is actually used when it comes to the economic space a lot. Okay, the pure economics person will look at the economic factor. Like I said, depending on your definition, your problem definition, you would know the kind of data to use for whatever you intend to use. But they are very applicable in economic issues. I hope I have answered your question. What is the next question? Okay, I see another question that says there's relationship optimization and data science. Okay, optimization and data science. I think optimization falls under data science. Optimization is encapsulated in data science. So when you come to algorithms, the use of algorithms, we use optimization to know whether your predictions are right or wrong. So they are interrelated. In fact, if you want to use optimizations, you are actually in the space of data science. But depending on what you do and what you actually want to optimize, that's where the question comes. But they are interrelated. It's a subset of data science because we use them in our algorithms. Then I am seeing another question that says, where do we draw the line between data science and data analytics? Okay. Okay, so in terms of data science has to do with the science of it. Okay, when I talk about the science of it, I mean the statistical bit of it. So when you come to, let me use a typical case of correlation and regression. Okay, the science, the application of some of these statistical themes, or if you want topics, is the analytics version. But the science of it encapsulates analytics. It goes beyond it. The science looks at the business aspect of it. The analytics has to do with just analyzing the data, bringing output. The science goes to, once you have gotten the output, what is the implication to the business? Though sometimes when you read some material, they look at it interchangeably, right? But the analytics version is putting the data in, applying the tool you want to apply, the model you want to apply, and getting your output. The science has to do with beyond the output. What do I do with data? How does it inform decisions at management level, at the department level? That is the distinction. Okay, so the analytics bit has to do with models, creating models. Then there's another question that has to do with SPSS, data, and data. Okay, so I would think that, at least as far as I'm concerned, SPSS and data has been used more for social science research analysis. Beyond that, I know there are versions that have been improved now to be able to handle some data science. But really, when you come to the business world, its application is very less. In the business world now, the application of SPSS and Stata are very less. Of course, when you join NGOs and research firms, they use these things for analysis. But the kind of analysis they do is not that high. So you can easily use SPSS and data. But in the business world, I would say, if you really want to come to the business space, it's Python or R and SQL. Okay, there's also okay. No, I think that is the last that's the last question I've answered. Okay, I see Lucas. Lucas says that how data science can create and direct the actions. What will make, please, when you are typing, it's a bit difficult to, if you to type clearly, I would be able to respond to your question. Okay, I think that's about it in terms of questions, unless there is any other question. Hello?
Okay. Okay, Mark, I want to thank you so much for that awesome presentation, actually, on behalf of Dynamic Data Analytics.
I think we cannot hear you, Paul. You are breaking off, please. Paul, only our moderator, we cannot hear you well.
I see.
And we're actually looking forward to more of similar webinars. You've actually shed a lot of light on data science, and
Hello? I see another question coming from Rwanda that says we should bring the company to Rwanda. I see. All right. So let me add a few words to what I have shared. Finally, I would like to say that data science in Africa is still at its infant stage. we have not begun. So it is an opportune time for every one of you to take advantage of it. Like I have shared the plan with you. Identify a space where you want to go to. Get a skill. Train your mind. Spend majority of your time training the mind. And that is when you get exposed to what is going on in the industry. I always say academic education is very important, but be mindful that beyond the academic education, you'll be going into industry. So the question is, how are you preparing yourself for industry? Data science is at its infantile stage in Africa. Take advantage of it. Thank you.
Yes, thank you so much, Mark. Actually, the presentation has been awesome and we are grateful. I believe every participant has actually taken on something that is great and that will help us expand our careers. Thank you so much. And we hope for more of similar webinars. Thank you.
Thank you. Thank you. Thank you so much, Mark. And
Thank you.
okay, thank you. Bye, guys. Okay, bye. I'm ending up the webinar.